Welcome back, guys. So today we're going to be looking at topic 6.10, which is on using unit logarithms to solve equations. Now, in this lesson, we're going to be taking everything that we've been working on in the last few lessons, looking at how to convert from exponential form to logarithmic form using our log laws, and we're going to use all of those things to combine them together to solve equations. All right, so let's jump right into it. So first of all, before we get into the examples, let's take a look at what we've learned so far. So first of all, we looked at how to solve exponential equations using a common base. So if you remember, if we have 2 to the x equals 64, and we want to solve this equation, we can write 64 as base 2. So 2 to the x is equal to 2 to the 6. And if our powers are equal and we have the same base, then we can equate our exponents and we have x equals 6. We can do that with more complicated equations as well. We have 9 to the x equals 3 to the x plus 3. 9 can be written as 3 squared, and using our power rule for exponents, we can combine our exponents. So 3 to the 2x equals 3 to the x plus 3. Again, once our powers are equal and our bases are the same, then we can equate our exponents. So 2x equals x plus 3, and then we solve for x. Later on, after we did that, we looked at solving equations by converting into logarithmic form. So if we had 3 to the x equals 42, we can rewrite this in log form and solve. Now, the reason we have to do that is because we can't write 42 as base 3, but we can still estimate what that value is going to be. So for example, we know that 3 cubed is 27. And we know that 3 to the 4th is 81, and we know that 42 falls somewhere in between there, and probably right about halfway in between them. So we could estimate based on this that x is going to be about 3.5, so about halfway between a 3 and a 4. Now, in order to actually solve the equation, we would have to write this in logarithmic form, and so we write log base 3 of 42 equals x. And then in our calculator, we can take log base 40 or log of 42 divided by log of 3, and we actually get 3.4. And so the main purpose for estimating is just to see if we're on track with our answer. We can't just assume that the calculator is always correct because we can make silly calculator errors, typos, maybe mix up our numerator and denominator. So estimating gives us a good way to kind of track whether our answers make sense. Now, we also looked at how to solve exponential equations using a graphing calculator when we did some of the word problems at the start of the unit. And so in order to solve an exponential equation, we can put our equations in as y1 and y2. For example, if I wanted to solve 3 to the x equals 42, I could put y equals 3 to the x as y1, and I could put y2 as 42. And so if we intersect those 2 points, we would have y equals 3 to the x and y equals 42, and those 2 points would intersect at 3.4, comma 42. All right, so let's do some practice with these equations first. All right, so for the first question, we're asked to solve the following equations, expressing the solution as an exact value in the form log of m over log of n, and then write to 3 decimal places. So essentially, we're going to solve the way that we've been doing this. So 5 to the x equals 8 cannot be written with common bases, so we need to use this second step here of solving by converting to logarithmic form. So we write this as log base 5 of 8 equals x, and then we can rewrite that expression as log of 8 over log of 5 equals x, and then putting that into our calculator, we get x equals 1.292. For the second equation, we have 7 to the x plus 4 equals 52. Well, our first step is to subtract 4 from both sides. So we have 7 to the x equals 48. 7 cannot be written as, 48 cannot be written as base 7. So then we have to write it as a logarithm. Now again, if we're using our estimation, we know that 7 squared is about 49. So we know this number has to be really close to 2, but not quite. All right, so writing this as a logarithm, we have log base 7 of 48 equals x. X is going to equal log of 48 divided by log of 7. and putting that into our calculator, we get 1.989. All right, let's take a look at a word problem. So example number 2 is a word problem that we had seen earlier in the course or earlier in the unit, and we were just solving with our calculator. Now we can actually solve this using either our calculator or algebraically. Today we're going to go through it algebraically. So the example says, according to Statistics Canada, in the 21st century, Canada's population has been growing at an average annual rate of 1%. The exponential equation P equals PO times 1.01 to the n can be used to predict the population n years after a known population PO. I first want to draw your attention to the 1% and the formula. Notice that we have 1.01. That means 100% plus the 1% population growth. And as a decimal, that's 1.01. That's going to come in handy when we get into solving equations next week, where we have to create our equations on our own first. All right, so that's just setting up the formula, telling us what everything stands for. P is the population, n years after the known population. So PO stands for our initial population, P stands for the new population, and n is the number of years. Now the actual question says, if the Canadian population at the beginning of 2001 was approximately 30 million, estimate the year in which the Canadian population will reach 50 million, assuming the same average annual growth rate. Well, we start by labeling our variables. So we have PO, so our initial population is 30 million. Now you can write 30 million like 30 with 6 zeros. However, because both are in millions, we can just write PO as 30 and our new population as 50. And then we're being asked for how many years does it take. So our formula is P equals PO times 1.01 to the n. P is 50, PO is 30, and we have 1.01 to the n. So for solving, we're going to divide by 30 on both sides. Now, 50 over 30 reduces down to 5 over 3, so we have 5 over 3 equals 1.01 to the n. Now, to get n by itself, we have to write this in logarithmic form because we can't write in the common bases. So we're going to have log of base 1.01 of 5/3 equals n. So putting that into our calculator, we're going to have log of 5/3 divided by log of 1.01. All right, so putting that into our calculator, we're going to have log of 5/3 divided by log of 1.01. And that gives us 51.337 years. So n equals 51.337 years. So about 51 years. Now, if you were asked specifically for what year that would be, we know that this started in 2001. So if we add that to 2001, so in about 2052, we would expect the Canadian population to be about 50 million. All right, let's take a look at another example here. So when we are solving using our calculator, we put everything in as y1 and y2. So this equation asks us to consider the equation 5 to the x equals 8. And it says to use the intersection method, so in other words, the graphing method, to solve the equation to 3 decimal places and compare your answer to the solution above. So if you notice, we solved 5 to the x equals 8 above, and we had 1.292. So we would be expecting the same answer here. So when we put this into our calculator, y1 is going to be 5 to the x, and y2 is going to be 8. And based on the graph here, we can adjust our window settings. So let's take a look at this equation. So y1 is going to be 5 exponent x, and y2 is going to be 8. And based on our window settings, we're going from -1 to 4, and going up by ones. And then our minimum, we're going from -7 up to 10, and we're going up by ones. So graphing, we would have something that looks like this. And finding our intersection point, second calc, 5, enter, enter, enter. We have our intersection at 1.292 and 8. So graphing, remember our exponential functions go through 1 and we know it's intersecting up at 8 at about 1.292. So graphing this, and I think 1 goes through at about 5. So graphing our function, we have this, and we have a line intersecting here. And again, checking that intersection point, it happens at 1.292 and 8. So our intersection point here happens at 1.292, 8. So our solution is x equals 1.292, which is the same as what we had earlier. All right, now when we're solving more complex exponential equations that have two variable exponents, we can't just solve them by simply converting to logarithmic form. So if we have exponents on either side of the equation and we have two different bases, we can't just solve by converting to log form. Now, if these can be written as the same base, then we might be able to equate our exponents. But in this case, 8 to the 3x and 5 to the 2x minus 1, these do not have the same bases, nor can they be put in the same base. So we have to look at solving this another way. So if two quantities are equal, then the logarithms of the two quantities are also equal. And so we can actually take, or what you'll hear me say often is take the log of both sides. So the equation 8 to the 3x equals 5 to the 2x minus 1 can be solved by taking the logarithm of each side and then solving for x. So I'm going to walk you through this example here. We have 8 to the 3x on one side and 5 to the 2x minus 1 on the other side. The first step is to take the log of both sides. Now we haven't changed anything because they're still they're still representing equal values. Now from here we're going to simplify using our log laws. So the 3x is going to come forward and the 2x minus 1 is going to come forward. Now notice the 2x minus 1 is in brackets because that represents an entire expression multiplied by log 5. So we have 3x log 8 and 2x minus 1 times log 5. So we multiply the log 5 through, so we're expanding 2x log 5 minus log 5. And our next step is to combine our like terms. So we're going to move the 2x over, so subtract 2x log 5. And now we have 3x log 8 minus 2x log 5 equals negative log 5. After this, we're going to factor out an x. And from there we can divide. So we have x equals negative log 5 divided by 3 log 8 minus 2 log 5. Now putting in our calculator, we would have to make sure this part was in brackets. And so at this point we can put that into our calculator and get our answer. Y1 and Y2 can also be used if we want to solve graphically. So we can make 8 to the 3x as Y1 and 5 to the 2x minus 1 as Y2. And in both cases, we'll get an answer of x equals negative 0.533. All right, so a couple notes before we get into some examples. We can take the log of each side of any exponential equation to any base. But because our calculator is already programmed for base 10, using our calculator base makes the most sense. Now, if the base of an exponential equation is e, then instead of taking the log of both sides, we're going to take the ln of both sides, so ln of both sides, and then solve. And so we'll look at an example of this as well. All right, so let's take a look at some examples. First of all, we're asked to solve the following equations by taking the log of both sides. Now, before we get into that, I want to show you that we can solve these using other methods. 4 to the x equals 10 to the equals 1024 can be solved by writing these as common bases. So 4 to the x can be written as 4 to the 5, and so x is 5. It can also be written as taking or rewriting as a logarithm. So log base 4 of 1024 equals x, and 5 equals x. So while we're going to solve by taking the log of both sides, we can solve these other ways as well. So sometimes you're going to have a choice in which way that you solve an equation. Other times you're limited based on what options you have. All right, so if we want to take the log of both sides, we're going to write log of 4 to the x equals log of 1024. Using our exponent or log laws, we can bring this x forward. And so we have x log 4 equals log of 1024. Now to get x by itself, we're going to have log of 1024 divided by log of 4. And putting that into our calculator, we're going to get 5. Now for the next question here, we have 4 to the x equals 2 to the x plus 3. Once again, this can be solved by using common bases. So 2 to the 2 to the x equals 2 to the x plus 3 gives us 2 to the 2x equals 2 to the x plus 3. And then we can set our exponents equal to each other and solve. So we can solve this by writing it as a common base. We're going to solve it today by taking the log of both sides. All right, so for this question here, we're going to take the log of both sides. So that gives us log of 4 to the x equals log of 2 to the x plus 3. Again, nothing's changed yet because they're still equivalent values. Using our log laws, we're going to bring those x's forward and the x plus 3 forward. Remember to put the x plus 3 in brackets. So we're going to have x log 4 equals x plus 3 in brackets log 2. Our next step is to expand. So we're going to bring the log 2 inside the brackets. That gives us x log 4 equals x log 2 plus 3 log 2. Now we have an x on either side of the equation, so we want to combine like terms. So we're going to have x log 4 minus x log 2 equals 3 log 2. And just like before, we're going to factor out an x. So that gives us x times log 4 minus log 2 equals 3 log 2. And then our final step to get x by itself is to take 3 log 2 and divide by log of 4 minus log of 2. Now again, remember when you're putting this in your calculator, brackets are extremely important. So let's take a look at how this goes into your calculator. All right, so we're going to have 3 log 2, close your bracket, divided by, open brackets, log 4, close your bracket, minus log 2. And again, newer calculators might look slightly different when you're entering it. And we get 3. So we have x equals 3. All right, let's take a look at example number 5. So we're asked to show that the solution to the equation 5 to the x plus 2 equals 9 to the 2x plus 3. And we want to show that that can be written as this expression here. And then after we have that, we're asked to evaluate to 2 decimal places. So normally if we're doing any type of proof or verification, we would use left side, right side. Because ultimately we're just simplifying this equation, I'm going to do it without left side, right side today. So simplifying this equation, we're going to start off with 5 to the x plus 2 equals 9 to the 2x plus 3. I cannot write these as the same base, and I can't just rearrange into logarithmic form. So my only option is to take the log of both sides. So I'm going to have log of 5 to the x plus 2 equals log of 9 to the 2x plus 3. Now, once you get quite comfortable with this, a lot of people will often skip this step and just go straight to the next step because we know that that exponent's coming forward. So x plus 2 in brackets log 5 equals 2x plus 3 in brackets log 9. So if you're comfortable with skipping that first step and going straight to the second step, that's fine by me as long as you're understanding the math behind it. All right, so multiplying this through, we're going to have x log 5 and 2 log 5. So x log 5 plus 2 log 5 equals 2x log 9 plus 3 log 9. Now we want to combine our like terms, so I'm going to bring my x's to one side and my numbers to the other side. So this is going to give me x log 5 minus 2x log 9 and 3 log 9 minus 2 log 5. All right, my next step is to factor out my x's. So that gives me x times log of 5 minus 2 times log of 9 equals 3 log 9 minus 2 log 5. All right, now in order to get x by itself, I'm going to have 3 log 9 minus 2 log 5 all divided by log of 5 minus 2 log of 9. Now again, this can be put into your calculator in one step, but it's important that you have your brackets. So if we go back and double check, we wanted to have 3 log 9 minus 2 log 5, which we have, divided by log 5 minus 2 log 9, which we also have. All right, so our last step is to put this into our calculator. So we're going to have 3 log 9 minus 2 log 5. Now I'm going to actually hit enter here first, and then I'll divide by the next part. So divide by, in brackets, log 5 minus 2 log 9. And that's going to give me negative 1.211 to 2 decimal places. So negative 1.21. Again, now you could put this in your calculator in one step, but often that gets really messy. So if you see this here, we're going to have 3 log 9, you got to close that bracket, minus 2 log 5, you got to close that bracket, and then in the bottom here we've got log 5, close your bracket, minus 2 log 9, and close your bracket. So we've got quite a few brackets that we need to focus on, but we'll still get negative 1.21. All right, let's take a look at one last example, and this is where we're dealing with the e value. So we're asked to solve the equation 8 times e to the negative 2x plus 7 equals 12. So first we're going to solve this as an exact value, and then we'll put it into our calculator. So we start off with 8 times e to the negative 2x plus 7 equals 12. Just like any equation, we want to isolate our x. So we're going to start by subtracting by 7. So 8 times e to the negative 2x equals 12 minus 7, which is 5. Then we're going to divide by 8. So we're going to have e to the negative 2x equals 5/8. Now at this point, we can take the log of both sides. However, because we're dealing with base e, we're actually going to take the ln of both sides. And so rewriting that, that gives us negative 2x times ln e equals ln of 5/8. Now, if you remember from our identities before, ln e actually represents 1. So that cancels out. So by taking the ln of both sides, we've actually canceled things out and it gets much simpler. So we're now going to have negative 2x equals ln of 5/8. So to get x by itself, it's going to be ln of 5/8 divided by negative 2, or rewriting that, we have negative 1/2 ln 5/8. So we put these in our calculator, we get negative 0.5 ln of 5 divided by 8. Or we can put this in and we have ln of 5/8, so ln of 5 divided by 8 times negative 0.5. And that would give us 0.235. So we can enter it in either way and we'll still get the same answer. So entering that in, we have x equals negative 1/2 ln of 5/8 gave us 0.235. All right, so there's now a number of ways that you can solve an equation. Taking the log of both sides will work in all cases, but sometimes putting things as a common base or writing going from exponential form to logarithmic form are quicker. But you have a multitude of methods here now. So go and do some practice questions. Ask if you have questions or need any help. Have a great day, and we'll see you soon.